Honors Geometry, Notes 13.3, Inscribed Angles. Definition. Inscribed angle. An angle with the vertex on the circle and whose sides are chords. So this picture shows an inscribed angle. Now an inscribed angle will have what's called an intercepted arc. What you see here in green is the intercepted arc. Now I'm going to contrast this with a central angle. These are different animals. We get an inscribed angle and we have a central angle. An inscribed angle, is the theorem, is half its intercepted arc. So the measure of angle ABC is half the size of the measure of arc AC. Or you could say the measure of arc AC is twice the size as the measure of angle ABC. Let me put some numbers in here and it'll make it seem more real for you. If the measure of the inscribed angle is 50 degrees, then the intercepted arc is twice that, which is 100 degrees. If you contrast that with a central angle is going to have the same degree measure as the intercepted arc. Subtle, but different. Theorem 13.8. An inscribed angle whose intercepted arc is a semicircle measures 90 degrees. So in this picture, the intercepted arc is a semicircle. So it's telling us that the inscribed angle here has to be 90 degrees. It makes sense because this has to be half of 180 and half of 180 is 90. This is just a more specific version of Theorem 13.7. 13.9. Inscribed angles on the same intercepted arc are congruent. That should also make sense. So here's the intercepted arc, whatever that is. The measure of the inscribed angle here has to be half of that. The measure of this inscribed angle has to be half of that. If they're both half of the same number, then it stands to reason that they're going to be the same number. They are congruent to each other. Definition. Cyclic quadrilateral. Quadrilateral, four-sided polygon, that is inscribed in a circle. Inscribed means that each of the points, each of the vertices are on the circle. Cyclic quadrilateral theorem. Opposite angles in a cyclic quadrilateral are supplementary. So that means angles A and C are supplementary. Likewise, angles B and angle D are supplementary. Supplementary means, remember, if you add up their measures, you're going to get 180. Let's check out some examples. Find the measure of angle 1 and the measure of arc 2. This 38 degrees is a central angle. A central angle is the same as the intercepted arc. So that means the measure of arc 2 has to also be 38 degrees. An inscribed angle, which is what the measure of angle 1 is, has to be half the intercepted arc. So that is half of 38, which is 19 degrees. Number 2, find the measure of angle 1 and the measure of angle 2. This picture is a little misleading, but this angle here and this intercepted arc have to be the same because the central angle is the same as the intercepted arc. Easy enough. Angle 1 has an intercepted arc that's this 114 as well. So we got this angle, and we got this intercepted arc. According to the theorem on the other side, the measure of this, I think I might have said central angle, measure of this inscribed angle has to be half of the intercepted arc. Half of 114 is 57. There's different ways to do these problems, by the way. You can use anything that we've learned this year. We could have used isosceles triangles to figure that out, angle sum theorem, supplement theorem. There's lots of ways to get to this angle. Exterior angle theorem also would apply to that. Number 3, we got the measure of angle 2 we're trying to find and the measure of angle 1. Measure of angle 1 is relatively easy. It's not an angle. Measure of arc 1 is relatively easy. It has to be double the inscribed angle. Makes that 36 degrees. Let's add this to the picture. Measure of angle 2 is going to be half of whatever this is. We don't know what that is. We can figure it out because if you travel all the way around the circle, it should be 360 degrees. I'm just going to assign this a variable. X plus 100 plus 36 plus 134 has to equal 360. 36 and 134 would be 170 plus another 100 would be 270. It makes X 90, which does not answer a question. We did this first, we did the second. My work's going to be not laid out in a logical manner, so I'm going to number my steps. The measure of angle 2 is half the intercepted arc, so that's half of 90. Half of 90 is 45. Here's a release question. This is from the state of Ohio. Quadrilateral ABCD is inscribed in circle O. What's the value of y? This is a cyclic quadrilateral, and according to the cyclic quadrilateral theorem, opposite angles y and 83 have to be supplementary. That makes y 97. If you know that theorem, this is super easy. If you don't, this is as close to impossible as you can get. Number 5, not a release question, but a similar concept. This is a cyclic quadrilateral. Opposite angles have to be supplementary. So 10x plus y plus 100 have to equal 180. Likewise, 2y plus 94 plus 9x plus 14 have to be 180. Now the unfortunate part for us is each of these equations has two variables, so they're unsolvable. Fortunately for us, we can use system of equations to figure this out. Let's simplify each of these. I'm going to subtract 100 from both sides here. This other one, I get 9x plus 2y. I'm going to subtract 94 and 14 from both sides and get 72. I'm going to solve this first equation for y. I'm then going to plug this in to this equation here for y and get 9x plus 2, replacing the y with 80 minus 10x. Put this in for the y because they're equal. Now we have an equation in one variable. Distribute. 2 times 80 is 160. 2 times a minus 10 is a minus 20. We combine like terms, we get negative 11x plus 160 is 72. If we subtract 160 from both sides, we get negative 11x equals negative 88, which makes x 8. Question? There was no question. Let's assume this question asks us to find the value of x and y. Should be directions. I apologize if there aren't. Once we know that x is 8, we can go into the equation that y is already by itself. We're going to get 80 minus 80, and y is 0. See if this makes sense. Put an 8 into this, it's 80. Put a 0 into this, it's 100. That would make that 180. Put a 0 in for this, it's 94. Put an 8 in for this. Yeah, it looks right. Good enough. Number 5 is another free response question. Teacher draws circle O. This free response question is from the state of Ohio. It's a release question. Angle RPQ and angle ROQ as shown. So that information tells you nothing, except for O's in the center. The teacher asked students to select the correct claim about the relationship between the measure of angle RPQ, it's this angle here, and measure of angle ROQ, that's this angle here. So before we get into these claims, let's just think about this. Measure of angle, instead of putting that, let me do this. 1, 2. Measure of arc RQ has to also be 2 dashes. Remember, this inscribed angle is going to be half of this arc, which means in turn it's half of the inscribed angle, or half of the central angle. So the measure of angle RPQ has to be half of the measure of angle ROQ. Let's look at the claims. Measure of angle RPQ is equal to the measure of angle ROQ. No way. Measure of angle ROQ is twice the measure of angle RPQ. This one is twice the measure. So that is a yes way. Which claim is correct? Justify your answer. Claim 2 is correct because inscribed angle RPQ is half the intercepted arc and central angle ROQ is equal to its intercepted arc. I think that's a good enough explanation. That concludes 13.3. Please do the homework that accompanies this.